What is metadata? Metadata is descriptive information about data or content. It provides details about various aspects of the data, such as its origin, format, structure, and context. Metadata helps users and systems understand and manage data more effectively. It can include information like the author, creation, date, file size, and keywords associated with a document, among other attributes. Metadata is crucial for organizing, searching, and retrieving information in various digital systems and databases. XML or Extensible Markup Language is a markup language that is designed to be both human readable and machine readable. Characteristics of XML. Attributes. Elements can have attributes, which provide additional information about the element. Attributes are defined within the opening tag and have both a name and a value. Data separation. XML separates data from presentation. It focuses on the structure and content of data rather than its visual representation. Platform and language independence. XML is platform independent and can be used with various programming languages and operating systems. Text-based. XML documents are primarily text-based, making them human-readable and easy to create, edit, and parse with a wide range of tools. Support for metadata. XML is often used to represent structured data and metadata, making it suitable for application such as data interchange, configuration files, and markup of content for the web. Standardized. XML is a standardized format with defined specifications, making it a reliable choice for data exchange and storage. Namespaces. XML supports namespaces, which allow you to avoid naming conflicts when using XML elements from different sources or applications. Hierarchical structure. XML documents have a hierarchical structure consisting of elements nested with other elements. This hierarchical format makes it suitable for representing structured data. Tags. XML uses tags to define elements. Tags are enclosed in angle brackets and come in pairs with an opening and a closing tag. Extensible. XML extensible, meaning you can define your own tags and structures. This flexibility makes it widely adaptable for a variety of applications. Case sensitivity. XML is case sensitive, meaning that element and element are treated as different elements. Well-formedness. XML documents must adhere to a certain rules to be considered well-formed. This includes having a single root element, properly nested elements, and correctly closed tags. Materials and equipment like paper, pens, and chalkboard. Limited access to education materials and information. Teaching and learning typically occurs in an in-person classroom setting. PD. Document type definition. Define the structure and organization of an XML document. They specify which elements are allowed, their hierarchy, and the relationships between them. Validation. DTDs are used for validation. They allow you to check whether an XML document adheres to the rules and structure defined in the DTD. Validation can help ensure that XML data is correctly formatted and follows the intended structure. Element definitions. DTDs define elements and their attributes. You can specify the names of elements, their data types, and whether they are required or optional. Attribute declarations. DTDs specify the attributes that elements can have. You can define the names, types, and default values of attributes associated with elements. Entity declarations. DTDs support entity declarations. Entities are placeholders for text or other data, which can be reused throughout the document. This is useful for defining characters. Data types. DTDs allow you to define data types for an element content. For example, you can specify that an element's content should be a string, a number, or a date. Default values. DTDs enable you to set default values for elements and attributes. This is useful for specifying values that are automatically applied if they are not explicitly provided in the XML document. Complex elements. DTDs can describe complex elements which can contain other elements, text, or a combination of both. This allows for the creation of intricate data structures. Modularity. DTDs support modularity and reusability. You can create separate DTD modules and include them in multiple XML documents, which promotes consistency and reduces redundancy. Public and system IDs. DTDs can be referenced in XML documents using public or system identifiers. This allows for flexibility in locating and retrieving the DTD when validating XML data. DTDs support general and parameter entities, which can be used to define and reference pieces of XML content for reuse. Limited expressiveness. DTDs have a somewhat limited expressiveness compared to the other schema languages like XML schema or LAX schema. They may not capture all possible constraints and data types as precisely. DTDs are recommended in situations where backward compatibility with existing systems or legacy data is crucial. If you need to validate XML documents against older standards, or when you have limited control over the schema, DTDs are a good choice. DTDs are often used when dealing with legacy systems that rely on DTDs. Interoperability with systems that use DTDs is necessary. Simplicity and lightweight validation are sufficient. DTDs are less expressive and flexible compared to other schema languages. They primarily focus on document structure and are suitable for simpler XML validation needs. XML schema is recommended for more complex XML validation requirements. It offers a wide range of data types, element declarations, and advanced features, making it suitable for intricate data structures and strict validation. XML schema is commonly used when detailed and strict validation rules are essential. Complex data types and constraints need to be defined. Extensive documentation and tool support are required. XML schema provides rich data type support, precise control over element and attribute constraints, and comprehensive validation capabilities.